Okay, now that we've talked about addition and subtraction, we are ready to talk about multiplying complex numbers. Now, when you multiply complex numbers, you treat them like you would any polynomial. So, if you have to multiply two polynomials, you would normally use the FOIL method, especially if they were binomial terms. That's the same idea you use when you are multiplying complex numbers. You will try to FOIL your complex numbers as well. We'll start out with a simple example. In this one, you are multiplying 5i with 125i. So basically, you just multiply the numbers together and multiply the i's together. So you will multiply 5 into 125, okay, the numbers, and then you will multiply the I with the I. Okay, so what will 5 times 125 give us? Okay, if you multiply these two together, you should end up with 625. Okay, and I times I, we know, will be I square. And since we know I square equals -1, you'll go ahead and change I square into -1, and your final answer will actually end up being -625. Anytime you end up with I square in your answer, you always want to change the I square into -1. Never leave it as I square, because that will be considered incorrect, okay? Always change I square into -1, and that makes your number a negative number, okay? And this will be the answer to these two, the product of these two numbers here. We'll go ahead and look at a couple more examples. Let's say we have an example of this form. 7 minus 2i multiplied into 3 plus I. Now this is where you can see you have two terms in each complex number. This is in the standard form. So just like binomials, you will treat this as, like they are polynomials with two terms, and you will use the FOIL method to multiply these. Okay, so you'll start by multiplying 7 into 3, which will give you 21. Okay, then 7 times I will give you a positive 7i. Negative 2i into 3, so you multiply the negative 2 into 3, which gives you -6, and you'll carry over that I. And for the last one, you will end up with -2i times I, so that will give you -2. And then of course I times I will give you I square. Now you want to go ahead and simplify this. So 21 will stay the same. You can combine 7i and -6i, which will give you just 1i or just I. And then you have -2. Again, like I was saying earlier, you have I square. Write that I square as -1, and you will end up with 21 plus I. Okay, these two stay the same. -2 times -1 will of course give you +2, right? -2 times -1. Now you will see what happened. You started out with a 2i square, and now, a -2i square, and that has now become a +2. So you can now go ahead and combine these two, because it's a real number now. So 21 plus 2 will give you 23 plus I, and that will be your answer. So you can see it cleans up pretty well here, okay? Let's look at one more example on multiplication before we move on. Now in this example, you have 3 plus 2i and the whole thing squared. What does that mean? Basically that means 3 plus 2i times 3 plus 2i. Okay, so again, you will go ahead and use the FOIL method here. So let's go ahead and multiply these. 3 times 3 will give you 9. 3 times 2i will give you 3 2s are 6, so that will give you 6i. In the middle again, 2i times 3, 2 times 3 is 6, so that will give you 6i. And for the last term, 2i times 2i, 2 2s are 4. I times I gives you I square. Again, go ahead and simplify these. So 9, you can combine your middle term, 6i plus 6i gives us 12i plus 4. Again, I square, write that as negative 1, which will give you 9 plus 12i. 4 times negative 1 is negative 4, so of course these two terms stay the same. It's only here where plus 4 will become negative 4 once you multiply with negative 1. And now go back and combine the real parts, which is 9 minus 4, which will of course give us 5 plus 12i as our final answer. Okay? So just like you would work with polynomials, you try and do the exact same thing with complex numbers. Now there's another type of product I want to look at, and this is when you try and multiply complex conjugates. What do we mean by complex conjugates? Basically, if you take the complex number a plus bi, okay, and a minus bi, again you will notice that the terms are the same, a bi, it's only one is positive, one is negative. So when you have two numbers of this form, this is what you call them as complex conjugates, or you can simply call them conjugates. When you take the product of these complex conjugates, you know, a complex number and its conjugate, the product is always going to be a real number. And we'll go ahead and see why that is true. Now, if you remember, we had talked about conjugates when we were doing rationalizing the denominator. It's kind of the same concept here when you're talking about conjugates. So here we have a plus bi, and we're multiplying that with its conjugate a minus bi. So just to prove that the product is always going to be a real number, let's go ahead and see what happens here. So we'll FOIL this again. A times a gives you a square. A times bi, and of course you have a minus sign, so a times negative bi will give you negative a bi. You have positive bi into positive a, that will give you a positive a plus bi. And then bi times negative bi will give you negative b square, I square. B times b is b square. I times I is I square, and of course positive times negative gives you a negative over there. Okay, let's go ahead and simplify this. A square, you can see the two terms in the middle are opposites of each other. One is negative a plus bi, the other one's positive a plus bi. So the middle terms will cancel out. You're left with negative b square, I square, rewrite it as negative 1, and of course negative b square times negative 1 will become positive b square. Now remember, when we started talking about complex numbers, we said both a and b are real numbers. So if you take two real numbers and find the sum of their squares, you know this is going to be a real number. So anytime you have product of complex conjugates, your product is always going to be a real number. So let's apply that to some examples here. We're looking at 6 plus 7i, multiplying it with its conjugate. 6 minus 7i, again start by foiling your answer. So 6 times 6 gives you 36. 6 times negative 7i will give you negative 42i. Positive 7i times 6 will give you a positive 42i. Okay, and 7i times negative 7i, again positive and negative gives you negative. 7 times 7 gives you 49, and I times I gives you I square. Again, your middle terms are negative 42i, positive 42i. They cancel out, and you are left with 36 minus 49 and instead of I square, again we'll say I square equals -1. So that gives you 36. Negative 49 times -1 will give you a positive 49. And you can go ahead and add these two numbers now, and what will you end up with? 36 plus 49 will give you 85. And you can see you took the product of two complex conjugate and you ended up with a real number as your answer. We'll try this with one more example. And you have 12 plus 3i and 12 minus 3i. Now in both the examples that we did earlier, you saw that your middle term gets canceled out, and the answer, the product you are left with, is the first term squared plus the second term squared. So you can try and apply that to this one here just to see how that works. Okay, so let's try and see how we can work with this. You have first term squared, so first term is 12. You'll go ahead and square 12, plus your second term is 3. The b part is 3, so you'll go ahead and square the 3, and let's see what do we end up with. You end up with 12 square, which is 144. You end up with 3 square, which is 9, and 144 plus 9 will give you 153. Just to be sure that this works, go ahead and try doing it the long way. Okay, go ahead and FOIL the two terms and see what happens. So if you FOIL it, you will end up with 12 times 12, which is 144. Then 12 times negative 3i will give you negative 36i. 3i times 12 will give you a positive 36i. And then of course 3i times negative 3i will give you negative 9i square. So these terms cancel out. You're left with 144 minus 9 times negative I, because you replace your I square with -1. 144 plus 9. Now you'll see, same thing we had here, which gives you 153. So you can try doing it either of these two ways. Do it the first way if you think that's simpler and you can follow it, or just go ahead and use the FOIL method and you will still end up with the same answer.